Hi guys, I'm going to be talking about classes of needs satisfied by the control system. There are three major reasons why you need the control system: to suppress the influence of disturbance, to ensure stability of the system, and to optimize performance. In this particular video, I'm going to be focusing on how to suppress the influence of the external disturbance on a particular system. Now, let's consider a particular reactor. If I have my feed coming into this tank at a flow rate of F1 and at a temperature of T1. Now this is the tank. Now I need to heat whatever it is that is coming into this thing in order to get an output. Now whatever is coming out must be flowing out at a flow rate of F and temperature of T. You will notice that the temperature has changed. Now to heat up this, I'll need steam to heat it up. Okay, so now there is a boiler here, so I have steam coming in through this valve. Steam is coming in through this valve, so steam is S. Now when steam comes into this valve, any steam that is here will heat up your content inside the tank. Let's say for example our content is water, so steam will heat it up. Now this particular boiling mechanism here is like as if you're having a tube, a coily tube. Okay, this is how it looks like. I'm trying to give you a very graphic image. If you have a boiling tube, now as the steam enters this boiling tube and passes through, I told you it will be heating up the water here, and at the same time as it's heating it up, that's exchange of heat. This one will condense, so as it's condensing it comes out as water here. So here I have the condensate, let me call it cond. Okay, now what happens is that inside this tube, as the hot steam at very high temperature flows through, it transfers heat into this tank. After transferring heat into this tank, then it becomes liquid, okay, and comes out as the condensate. Meanwhile, on the other hand, you have your output coming out at temperature of T. Now we're told that is a well mixed, I'm assuming that is a well mixed reactor, so that shows that you need a mixer here. Okay, now you have every single thing you need here. Now this is a standard system, this is the way to be. You have a temperature coming in, now this steam will heat it up and you have your output at temperature of T. This is a standard example. Now because it is well mixed, that's because of the fact that it is continuously being mixed, so any value of temperature that you have inside the tank is the same that will be coming out, because it is uniform all around and is a continuous mixing process. Okay, so any value of temperature I have here is the same value of temperature that will be coming out of this tank. Now let's take an example. If for example now this was coming in at 30 degrees Celsius, okay, and I have hot steam at 400 degrees Celsius, okay, and this is coming out at 120. Now there's continuous mixing here, so if this one here is 120, whatever it is that will be coming out here will be 120. Now assume a situation whereby your feed temperature is changing. I pour in water. Let's assume that initially I poured in water at 30 degrees Celsius. The second time I now pour in water at, let's say, 50 degrees Celsius. The third time I pour in water at 60 degrees Celsius. That means I'm saying my F1 T1 is changing continuously. Now this one, if what is entering continues entering at 30 degrees Celsius, the whole process will be repeating itself if this 30 degrees Celsius doesn't change. But in a situation whereby you're having different temperature, that's entering at 30, entering at 40, entering at 50, different temperature, obviously your output will not be constant like you expect it to be. Now that's where a control system comes in. You notice that this, look at what we said here: suppress influence of disturbance. Disturbance means input. That means this input has been changed, so we want to suppress the influence of the change in this input. So what happens? We still have our steam coming in here. Okay, I still have my steam coming in through this boiler, and I have it coming out as a condensate, cond. Same thing is still happening. I have my steam here, S. Okay, this is the valve through which the steam will pass through. Then I have, in this case, what will now happen is that there will be a measuring device. The measuring device in this case is called thermocouple. So the thermocouple, I'm going to call it TC. The thermocouple will measure the temperature. Now do not forget, I want to achieve 120 degrees Celsius here, and because it's a well mixed reactor, continuous tiered tank, so is continuously being mixed. Whatever it is that is inside there is what will be coming out. Okay, so that means if I want to measure what is coming out here, I can just decide to measure what is inside here, since it's the same thing. Okay, so this thermocouple will measure the temperature inside this place. It will now send it, this thermocouple not controller, it will now send it into the controller. Now before it gets to the controller, it will send it to the signal point. In the earlier video I explained, I said signal point is where two or more things meet each other, two or more wires, two or more units, two or more processes is called signal point. So this is the set point. So the set point will give the signal point the temperature. Set P, the set point, it will give this signal point the temperature, that's TS. Meanwhile, the thermocouple would have already measured the temperature of this place, so it will send it to the controller. So these two things are going to enter the controller. Okay, so this is the controller. That's control. So now the controller will now send the message to the valve. It's just like a feedback controller. After the thermocouple has measured the temperature here, send it to the set point. So the set point will give this signal point its temperature, send it to the controller. The controller would have adjusted that, okay, this thing is not up to the set point. It tells the valve that we need more steam. Now the valve will now increase the steam. The valve will open more steam will be passed here to increase the temperature. This process will continue until you now get your final temperature. Now you can see the essence of a controller. Now what this controller has done is to help us suppress the influence of a changing T. That's the job that this thing has done here. It has suppressed the influence of a changing T. This value of T that was changing, of the feed that was changing. So this controller has suppressed the influence of it. So this is the major use of the controller system. So in the next video, I'm going to be explaining on how to ensure stability in the control system. Now there's something else we need to understand here. Now in this controller, if the temperature is greater than the T1, the controller will close. Now what do I mean temperature greater than T1? Now temperature is what is coming out, okay, and T1 is what is coming in. If the thermocouple has already measured and seen that this temperature is already greater, it will tell the controller that, okay, I need you to stop the steam from producing more steam. This temperature that we have here is already more than what we required. It's a very simple mechanism. If the temperature here is greater than the T1, that's TS in this case, now greater than the set temperature, if the temperature you are getting finally greater than the set temperature, the controller will tell the valve that, okay, close the steam, we already have more than what we require, close the steam, there's no need for you to continue. Now but if the temperature you're having is less than the set temperature, if it's less than the set temperature, that means you need more steam. So the controller will tell the valve that I need more steam, open up. The valve will open more steam into this place, and the process will continue until when the temperature will get to the particular point. This type of temperature is known as feedback control system, like I said earlier. It's also possible for you to keep the volume of this tank constant. If you decide to keep the volume of this tank constant, if for example this is the tank, I'm sorry that this one looks a little bit rough, but if this is the tank and I decide to keep the volume constant, now we all know that volume is equals to area times height. Okay, so that means I can keep the volume constant by keeping the height constant. That's a simple mechanism. Now the reason why I can't change area is that the area of this tank will not change. This is a rectangle, length times breadth. I can't change the area of the tank I'm working with. The only thing I can change is the height of the liquid that will be inside. As if I decide to keep the volume inside this place constant, I will have to keep the height constant. Now therefore, when the flow rate changes, now what is going to affect the height? Now remember that what we're doing before was temperature. This one had to do with temperature. Now the only way we can keep the height constant is flow rate. I'm going to explain the mechanism now. If, for example, I have water flowing into this place, let's say I open up a tap. If I open up a tap up to half, so I'll say, okay, if I half open a tap, it sounds a little bit wrong, but it's just for you to understand the concept. So if I half open a tap, all right, and the water inside this tank is getting up to 2 centimeter. That's if I half open the tap. You agree with me that if I fully open this tap, the amount of water here will increase. Automatically, the height of the water here will increase to about 4 centimeter. So that's just the simple concept. That's the simple concept. So to keep the height constant, you just have to keep the flow rate constant. That's what it's talking about. Half open, that's the flow rate. That's what I'm talking about. In a tap, if you half open, that's the flow rate. That's the rate at which the water is flowing out. If you have the height to be 2 centimeter, if you fully open the tap, you notice that it will increase to about 4 centimeter. So the flow rate is a major determinant on the height of the liquid. So if I decide to keep the volume constant, I must keep the height constant, and to keep the height constant, I must keep the flow rate constant. So we can see that the control system has a lot of things to do with operating this. Now the effluent flow constants, that's whatever it is that is coming out. Effluent means whatever it is that is coming out. So the effluent flow constant can be made constant, and once it's made constant, the volume is constant. That if F is constant, V is also constant. That's the meaning. So you can also apply this in your feedback. That's if you are told to give an example of a feedback control system. This is a very good example of a feedback control system. But do not forget that when we earlier started, we said that this is the needs, that these are the reasons why we need to use a control system to suppress the influence of external disturbance. In the next video, I'm going to be explaining on to ensure the stability of the process. I hope you guys understand. If you have any question, please contact me. Thanks. Bye.